Hello everyone, I welcome you all to this 30 days masterclass series on electric vehicle design. Today is day 29, EV model fabrication design. So today we are going to discuss about how we can design our own EV prototype. Right. So before I get into the topic, I welcome you everyone here. Yes, I welcome Shiva, Ramachandran, Hitesh, Lord, Vaishali, Arpreet, Janathanan. Very good evening, Tarun, Indrajit, Manikandan. Warm welcome participants. Sharath, Kushbu, Raj Singh. Very good evening. Arvind, Jamil, Vivek, Rehan. Very good evening, participants. Yes. About Pantech is a educational equipments manufacturing company. From Pantech, you can get lab equipments for ECE, EEE, computer science, IT related products. You can get it. And our vision is to help 10 million students to learn the technology in easy way. So far, we have trained about 10 lakh students. So this year, we are targeting 10 million students. I hope we can reach the list in detail. So we have discussed this. We fabricated the lab test completely in our laboratory. So the vehicle is perfectly running, and so this is our entire EV vehicle, right? So I will give you how we have developed from our things, right? So you can check one by one. So please try to engage with our entire class. I will tell you. I'm just waiting for your reply. If you are ready, please comment in the comment box. Yes, thank you, participants. Yes. So we have prepared this prototype exclusively for you. So in the internship portal, you can download all the content, and then how you can download entire uh, source codes of the hardware, and then detailed schematics of the hardware. Everything you can get it. Thank you, participants. Thanks for your active participation. And so in this hardware, so what are all the procedures to start your hardware design? So let us check one by one, and finally I will give you the demo. And in the tomorrow class, I will give you in detailed demo about what is the duty cycle, how you can download the code and all everything in the tomorrow class. So today we will plan the structure, and tomorrow we will get into the hardware implementation. Right. Right. So now let us take. So for the hardware design, so there are few basic steps. One is that specifications. You have to develop your own specifications. And the second thing is that vehicle structure. So you have to identify, and then you have to think yourself and how to develop the structure. But as per the standards, there are some basic structures are there. So straight away you can use it. So since the electric vehicle, so it's not as a conventional vehicle. So you can design your own electric vehicle because the control is very simple. Because the control is very simple. Right? Am I audible? Am I audible? I hope you all are getting it, right. Fine. Right. And after that, motor selection. So how you can select your own motor for your own vehicle. And finally the controller. So once the motor selected, then you can go for the controller selections. You can go for the controller selection. So this is the process while you follow. I mean, you have to follow while you design your own hardware. Right. If you need any components related to the prototype, you can ask me. I will try to give you the solutions from our laboratory. And we have a very strong supply chain management, so you can get from our pantech. You can get those. Fine. So now let us go for the specifications. So as per our calculations, so we have calculated the total weight of the vehicle is about 140 kilogram, and other length, and then width, and then rolling resistance. Actually I took that typical values rolling resistance, and then drag coefficient, gravitational force. So the maximum speed of the vehicle is about 20 km per hour. So this is the maximum speed of the vehicle, 20 km per hour. Then the frontal area, 0.45 meter square, and then velocity. So from this 20 km per hour, then you have to convert this as a velocity. And then rolling resistance watts, and then aerodynamic drag force watts. So, because actually this is a very basic prototype. It's not suitable vehicle for the hill climbing area. So hill area, so it's not suitable. So I have not included in that portion. So I plan to run the vehicle with a flat surface as well as that proper road. So this is the specifications I have selected. Certificate car provide oh my god, Mr. Rajan Kumar, please wait, the program is not yet finished. So March 10th only we will provide you the certificate. So for that you must have 25 days utterance form. You must have 25 days utterance form. Right? So please don't spam the chat. Please don't spam the chat. And the total tractive force. See, actually, if you want to run the vehicle, this vehicle for 20 km, then you have to apply a 438.91 watts. About 500 watts you require. About 500 watts you require. Right? So this is the basic motor power requirement to achieve this speed. To achieve this speed, so you must run this vehicle for 20 km per hour, then you must have 500 watts per meter. 500 watts motor power is requirement. Right? Is it clear? I hope you can develop your own calculator for your own specifications. Am I correct? MATLAB mobile app is not free. I hope you can develop your own calculator for your own prototype. Yes, thank you, Arjit. Right. So now I recommend you everyone. So please prepare this calculator and follow the procedure to fulfill your prototype. So now the next one is the vehicle structure. See, by default, the people will use aluminum or steel or carbon fiber. So these are the basic vehicle structures that people are using. But since our EV prototype, so you can use the square pipe steel material, and you can use that rod. And see, first you have to develop the rectangle shape. So that will be basic material, basic structure. So you no need to follow the as per that standards. So since based on your creativity, you can develop it. So actually, from our laboratory, we have developed this structure, EV hardware structure. So initially, we have developed this version, right? So this is the basic structure. So this structure will have a support to connect this 4 wheels. So this is the one wheel, and this is the another wheel, and one more. So it's a front view. Similarly, the back side we have a two type of wheels, right? So if you take the top view of the vehicle structure, so this is our structure we have developed, and here, so with this structure, so all the materials are the steel materials, and so this is the motor powered wheel. So here one motor will be there, and here another motor we have kept. So here another motor we have kept. So for this type of EV prototype, you can use the DC motor also. You can use the DC motor. So since we see, for example, if you want to run the vehicle on the as a consumer grade, so you have to follow all the standards. So due to the prototype, I have removed the standards. So first, my intention is just share the working flow and then control process everything to you. Just share the knowledge to you. So that is my intention. So on this intention, we are following this procedure. So actually, this procedure is common for any EV. So only thing, after this procedure, you have to include the standards. The standards nothing but the power from the power supply, and then from the vehicle, vehicle material, body structures, everything. There are some standards are there. So we have to follow. But in this prototype, we have not included the standards part. We included only that working flow diagram. Only the working flow diagram, right? Yes. Yes. If you have any questions, you please comment. If you have any questions, you please comment. I will try to give you the answers. Yes. I make designs for my own, and I have many designs for car or to bike. Okay, great, Mr. Mandal. So keep engaging on the design, right? So now we are going to go. We are going to select the motor, right? So first, if you take a motor, so there are that is the main component for the EV. So it's an electromagnetic device. So now we will convert electrical energy into mechanical energy. So the motor should have a higher efficiency, high instant power, and then high fast torque responses. So this is the ideal behaviors of the motor selections. This is the ideal behaviors of the motor selections. So you have to follow all these steps. You have to verify these points from the motor manufacturer data sheets, right? So in our vehicle, to understand the motor selections, you must cross this one. So motor performance graph. This graph is for all the motors. For ideal motor, the torque will be high when the speed is low, right? So this is the case for the IC engines also. And for what are all the types of motors are available? Can you just name any two names? What are all the motor types are available? Yes. For example, I will tell you one by one. I will tell you how to select from this graph. How to select the motor from this graph. So please check. Please wait, and then I will give you one by one the procedure. So before we get into the motor performance, we will check the types of the motor. So if you take a motor types, there are two types. One is a commutator motor and then commutator-less motor, right? So in the commutator motor, it's a DC motor. So simply we can take a PM DC motor. So other motors, it's not viable for the EV applications. So we will use a PM DC motor, right? So under the commutator-less motor, there are variety of motors are there, like PM BLDC motor, PMSM motor, switch reluctance motor, and squirrel cage induction motors. So these are the motors, right? So again, latest linear motors also available. Radial flux, axial flux motors also available. You can use it. Yes. So now, if you take this graph. We take this graph, see the DC motor performance will be like this. So this is the DC motor performance, right? So when the speed is low, the torque will be high. So once the speed increased, then the torque will drastically reduce. So here the range of speed versus the torque is very limited. The range of speed versus the torque is very limited. Whereas if you take an induction motor, the torque will the speed to torque will be like this. So here you may get extended range of the torque versus speed range. And if you take a BLDC or PMSM motor, so it will be ideal one. So the maximum the torque will be constant, and the constant power region, this torque will get reduced. So this is the ideal case comparatively. So now if you want to go for the DC motor for small type of applications, for the small type of EV applications, you can go for the DC motor. Why we have to choose the DC motor? Because initially the control mechanism is very easy. Comparatively DC, BLDC motor or induction motor or PMSM motor, DC motor, the controlling is very simple. So first, my intention is to share the complete knowledge about the controlling mechanisms. Simply, actually, the people, many people are here from the mechanical or automobile or electrical or electronics, computer science. So you must know what is the PWM, how the motor control actually in the black box or the PCB, how the functions are happening. So first you should understand. So on this vision, I selected the PMDC motor. But for this applications, you can use the BLDC motor also if you are well versed in the controlling methods. If you have a thorough knowledge on the controlling mechanism, then you can go for the BLDC motor also. So while you replace the BMDC with the BLDC, so you can handle the more speed range, and you can get a better performance, and you can avoid the noises and all everything. But obviously the cost will be high, right? So are you getting my point? If you understood the concepts, please comment in the comment box. If you understood the concepts, please comment in the comment box. If you understood the concepts, please comment in the comment box. For two-wheeler and then three-wheeler, so BLDC motor and then BMDC motor is suitable one. For the four-wheeler, you have to use the PMSM or induction motor or SRM motor. What are the uses of online internship? See, the online internship, here you can learn the new concepts. I will guide you how to develop these projects on step-by-step manner, and you can verify with me whenever you have a doubt, and then whenever you are in the trouble, I will help you to understand the concepts, and finally you will get certified from the Pantech. And if you post the certificate in the LinkedIn and then GitHub profile, then we will endorse you, right? So that will be a more value than the other methods. Thank you, participants. Thanks for your comment, right? And why there is a sudden dip between the constant torque region and then constant power region? So see, this is the ideal motor performance for the any motors like IC engine as well as the electrical motors. See here, the critical speed nothing but this is the rated speed. So till that rated speed, the motor will deliver the proper, constant torque. Once the motor reach the critical speed, then the torque will get reduced. At that time, the speed will get more increased. That is the ideal case. So EV bike, you can go with the BLDC motor. You can go with the BLDC motor. Right? If you have any more questions, you can ask me. I will try to give you the answer. Any more questions, you please ask me. I will try to give you the answers. What is the use of online internship? I think I answered your question, Mr. Krishna Rumeni. Yes, I answered. If you need more, please WhatsApp me. I will try to give you the answer. Second, I will take how to buy a motor. See, actually, for the motor purchase, there are a lot of manufacturers are there. Second, I will take a note. Just a second, I will take a link. Yes. So online internship give us any job placement. Yeah, if you want to get a job, you please connect me after this live. I will give you the guidelines how to get a job and then how to join in that program. Actually, this online program, the job placement is not assured. See, actually, if you're seriously about that job, getting the job, so the knowledge is only the 50%. Balance 50% is mindset. So both I mean both behaviors are more important. Of course, the mindset is more than the skill set. Right, so I will tell you, I will try to include those concepts and the coming forthcoming weeks. So we are going to launch that LinkedIn in master class. So in the class you will get a clear idea of what you can get after this graduations. So everything you will get it in that class. I will share you the registration link shortly, right? And yes, what is the maximum HP BLDC motor? How to do the losses overcome? Joseph, the actually maximum HP up to 30 kilowatt also the motor BLDC motors are available, and losses depends the load and then depends the type of converters which you are using in the uh, applications. That you have to take in care that one. And any more class on Simulink? Neetu Kartika. So classes actually we are going to start EV charging station class from the month of May, right? Thyristor means combined transistor resistor rectifier. It's not the thyristor is the advanced version of the diode. However, the losses overcome. See, actually, the losses overcome. Actually, you are talking about which loss? Either core loss or power. Power loss in the converter. So which loss we are asking? So that depends. That one we can discuss it. Uh, CAD CAM softwares. Right now we don't have a plan. So I will take a note, Mr. Mohan. Thanks for your comment. I will take a note for your requirement, and then in future I will try to include it. Right, and so as per, yes, why the brassless motor and a motor with brass? What will happen if motor has a brass? I'm not getting your point. Are you asking about the a brushless DC? Brushless DC, not a brass. It's a brushless. Brushes will be there. The DC motor. Am I correct? Just to confirm your question, Mr. Mandal. So now, so what are all the motors we can use it for the EV? What are all the motors we can use it for the EV? So you can use the DC motor and induction motor, BLDC motor, PMSM motor, and then SRM motor. So since for the two-wheeler and then three-wheeler you can go this DC motor and then BLDC motor. For four-wheeler and then multi-axle. For four-wheeler and then multi-axle, you can go with the induction motor, PMSM motor, and then SRM motor. So this is the typical type which you can use. You can select by very first the motor type, right? Can we change output frequency of motor control? How? Yes, you can change. So you just refer that yesterday class how to change the switching frequency of the inverter, so that you can change the motor control speed. Right? Yes. What about solenoid engine? Solenoid engine, I'm not much about that topic. Once tell about reluctance motor. So just tell me what is your question. So please ask me directly the question so that I can help you on this. Alright. So now I have selected. So since this is the prototype, I have selected that motor, 360 wattage motor. Two motors I have selected. So two motors. So I will tell you the name. See here. Just a second. I will tell you. Yes. See here, this is the one motor. Similarly, the other will have another motor. So now we have a two type of motors. So this is the two motors we have connected, and here the battery has been used. So since it's a prototype, we use a lead acid battery, but because the cost is very less. About this battery, about a 12 voltage 18 Ah battery I have used. Two batteries I have used, so it's a cost about 4,000 rupees. Suppose if you are going for the lithium ion battery, of course you may get a reduced weight, and you may get a better efficiency. Of course you have to bear about 8,000 rupees. So if you take a cost analysis with the lead acid and the lithium ion, so it will be double the charge. And here we use the hardware schematics. So whatever we discussed in the MATLAB Simulink, so the same kind of concepts only we have used. We have used the same kind of concepts, right? So here this circuit, you can download this circuits and the code, everything from the internship portal. You can use it. And this is the dashboard, and here the differential drive we we use that we got it from the old used vehicle. So simply we took that one so that you can reduce it. See, actually the total if you have about hardly if you have about 40 to 50,000 rupees, you can build similar kind of vehicle. You can build similar kind of vehicle with locally available material. No need to import anything. So locally available material you can build it, this electric vehicle, right? Yes, induction motor does not have high starting torque. Then how it is used for in the four wheeler? See here, start. The starting torque nothing but that is called a transient torque, right? The transient torque only the limitations. So there will be a pulsating torque, but there are a lot of solutions are available to smooth the pulsatings. So that is an excellent one. So now that Mahindra vehicles comes up with the induction motor only. Mahindra vehicles comes up with induction motor only, right? And see here in this vehicle, so we have developed. This is the single. Single person. Similarly, we have used that. Yes. See, we have added the load. So we have added the load, and 2 persons, and again we have increased the load for the 3 persons. So similarly, we have increased the load for the 3 persons. So the complete, see here, the two drive has been implemented. So this is the two drive, and so each and every drive will have a separate, separate bridges. So as per our DC motor control section, H bridge controlling method, and we have discussed in detail, right? About how to develop a controlling, and then how to understand the working principle of the PWM, everything. Right? If you have any questions, just a second, I will share you the attendance form. I will share you the attendance form. So I have shared the attendance form, so please check it. So now, yes, and this is called a driver model. So here the microcontroller has been used. So this microcontroller will sense our driver input. See here the driver input. See here we have modeled the driver input as a, see here here we have given the driver input. One is the acceleration and another one is a deceleration. So in the two leg we have given the two different input. So this two input is connected to the microcontroller via the dashboard. So here the dashboard has been used. So this dashboard will help you to change the forward mode as well as the reverse mode. Here the two switches. Yes, I will tell you. Yes. So here there are the two switches. Yes. See here now the vehicle is running under the forward mode. Now you can change the reverse mode. So how you can change the reverse mode in the sense here the two inputs are there. So this input the microcontroller will collect the input. The microcontroller will collect the input like a forward and then reverse. Similarly, acceleration, that is called a drive cycle. So the controller will collect these two input and it will generate the PWM for the H bridge converter. It will generate a PWM for the H bridge converter. Like this, we have to implement. So I will help you. So if you take this graph, yes, just a second. See, in the each and every motor has a 4 MOSFETs, right? So if you take this one, yeah. So this is the H bridge model. So as per this design, we use that one. So now the driver model will be connected for each and every MOSFET. So this is the driver model has connected each and every MOSFET, right? So can you able to understand the components? What are the components we have used? What are the components used? And then braking, so this brake actually here we have used the regenerative braking. To complete regenerative braking we used. So I will tell you one by one. Can you able to understand the components so that you can identify the components locally and then you can prepare your hardware. Right, so the battery power supply, this is the battery power supply and then inverter, and from this in one and then the motor will be get connected. Can you able to understand the components? What are the components which we are using? How to implement a MATLAB control design into the real-time controller? See, if you know the Arduino programming from the, actually I included in the internship portal how to program the MATLAB controller, MATLAB to program the Arduino. So that the basic control is enough. So that logic is common for even DSP also. That logic is common for DSP also, right? Alright, so this is the motor control. So since we selected the DC motor, PMDC motor, so the 4 MOSFETs has been used. So once if the as per the logic working principle, we can take a forward as well as the reverse. So now the motor power supply requirement. So the power supply requirement, motor power supply is a 24 voltage, then the gate driver power supply is a 15 voltage, and then microcontroller power supply is the 5 voltage. So this 3 type of power supply we need. So this three type of power supply we need. So but in the electric vehicle, so there are only battery. So the battery in actual EV systems there are two type of battery. One is the main primary battery. So that primary battery will power up to the motor, and then secondary battery will be there. So that battery will give you the auxiliary power supplies. So like that in our EV also we have used the similar kind of one. So this is the primary battery and this is secondary battery. So because actually since it's a mobility vehicle, so we cannot take a AC power supply to power up all these controllers, right? So the high power will have a high current flow functions. So we cannot disturb that current. So in that case, we have to use the auxiliary power supply, auxiliary battery. So from this battery, we can take a power from the gate driver as well as that microcontroller. Right? If you have any questions, you please comment. I will try to give you the answers. And finally, if you integrate this vehicle, then you may get a complete vehicle. I will share you the detailed circuit and detailed function flow. So actually, before this flow test, we have run this vehicle with lab test, and how to increase the duty cycle, how to decrease the duty cycle, and how that duty cycle will impact in our speed control. So everything in the tomorrow class, I will tell you. I have prepared this as a separate video to discuss about things, right? And now you can ask your questions. I will try to give you the answers. How to implement? Yes, okay. To implement this. Can you give small intro about regenerative braking? Yes. So the regenerative braking nothing but if you take a motor. So here you have connected the motor, right? So now assume that now the motor is under the running conditions. So running conditions is nothing but these two MOSFETs has been connected via the DC power supply. So now what you have to do, you have to remove the power from the motor. You have to remove the condition is you have to remove the power from the supply. Motor should be terminated from the supply. So that is the first one. Second one, you have to make a provision to short circuit of the terminal voltages. Right. So in that case, you have to open the MOSFET and you have to interconnect these terminals. And let us take A and B. You have to interconnect. So how you will get interconnect? If you connect these two things, if you turn on these two MOSFET, then energy will be dissipated quickly. So in that case, the motor will approach us to the zero speed immediately. So that method only we have followed here. So in this motor, in this brake, so the brake which we have implemented, so we have not implemented any the mechanical brake. The physical brake there is no any available. So we have used the regenerative braking. So how you can implement the regenerative braking? Simply you just remove the terminal voltage from the battery. And the second thing, in the Hutch bridge, you have to turn on the bottom MOSFETs simultaneously. If you turn on both the bottom MOSFETs quickly, then the motor will get stopped. The motor will get stopped. So tomorrow I will try to show you the vehicle on the road test. So this is our under laboratory we have tested. So in the tomorrow class I will show you the road test, how this vehicle is performing in the road. Yes. See here, just to take a detailed demo. Now the vehicle is under the forward mode. Now you can ask your questions. So the entire demo I have released. How many MOSFETs are required for building EV? Here we used two motors, so we took 4 MOSFETs. how many rates this vehicle. So this vehicle, I have used 260 wattage motor, 260 wattage, sorry, 360 watt motor. Two numbers I have used. PMDC motor I have used. PMDC motor. How to stop the vehicle immediately? See here, if you apply if you want to stop the motor immediately, you can use the regenerative braking. You can use the regenerative braking. This prototype vehicle run AC voltage? No. So here DC motor used. So DC motor we have to use. See, actually the YouTube video will be removed after the third day after released, published. If the speed is increased, if the load is increased, so you have to ensure that whether the motor can handle the power or not. See, actually as per our calculations, if you take these calculations, see the 360, 430 watts or 440 watts is motor is enough. But we have used about 760 watts. We have used 760 watts. So two motors has been used. So in that case, this vehicle can handle up to 3 persons. Tej Kumar, regenerative braking, charging the power also. Yes, that is also possible. So for the implementing the regenerative braking, so instead of approaching the zero speed, you can apply a electronic load. So in that case, again you have to put on a DC to DC converter and along with the supercapacitor. So after the supercapacitor, you can transfer the power to the battery. So that type of options you can implement. For this vehicle, for the cost purpose, I used PMDC motor. And also the controlling mechanisms. So how you can implement the control, like see, actually after this video you have to duplicate this video, right? So for that purpose only I have used this vehicle. Yes, you can implement a solar panel. So since the 24 voltage 24 voltage panel will help you to charge the vehicle, charge the battery. Right? If you have any questions, at regenerative braking, the battery will get charged. Yes, so we can include that facility. So actually, in this vehicle, I have not included that regenerative braking. I mean, in the next version, I will include that too. Yes. Now you can ask your questions. Vehicle stability and all, that is again the debatable point. So we have to increase a lot. We have to increase a lot. If you're talking about the stability and then performance, so in that case, we have to we have to verify the specifications. So the maximum speed of the vehicle is 20 km per hour. Maximum speed of the vehicle is the 20 km per hour. Any more questions? Regenerative braking, yes, of course, the regenerative braking will help us to charge the battery. We can use that energy. How much cost is to do this vehicle? So actually, I spent about 40 to 50 to 60,000 rupees. I think so. So I spent, and other components actually I took from my laboratory. Why didn't use induction motor? Yes, we can use. Actually, my plan is to develop a complete prototype with this PMDC motor and with BLDC motor and with induction motor and PMSM motor and then SR motor. So I am going to release the EV vehicle, electric vehicle with all the motors. 24 voltage motor. 24 volt motor. So if you replay the video, you may get the rating of the motor. So ratings, yes, this is the ratings. Certificate by March 10th, I will send you by email. We can use the BLDC motor also. Yes, of course, we can use the BLDC motor. Vehicle sudden ga yella stop cheyali sir. I'm not understanding your questions. Thank you, Mr. Arvind. Cost, you just check it in the website. You may get a variety of cost. So actually the battery charge and the discharge, there are the cycles, number of cycles are there. So that BMS if functioning well, then we can meet the warranty period. Which is the most efficient as of now, PMSM will give you the excellent performance. PMSM will give you the excellent performance for the high power meters. Why permanent magnet DC motor need the inverter? So that is not an inverter, that is a chopper. Thank you, participants. Attendance is in the top of the chat, so please check once again. So now you can download this detailed information from our internship portal. So I will share you the internship link. If you are interested, you can go ahead. Thank you, participants. Thanks for valuable time. And if you have any more questions, you can ask me. I will try to give you the answers. So internship registration link. So use coupon code EV batch 5. Attendance is top of the chat, so please check it. So the torque, if you want to increase the torque, then again you have to verify the specifications. Everything, whatever it may be, first you have to start from the specifications. What is your vehicle going to be? Here on Gouda. So please call me after this live to this number. So Mr. Ramachandran, so please check in the Google. I think it will be like a 2000 to 3000 rupees per motor. Top of the chat, attendance link. Carry the attendance. Attendance link is in there. So please check. Thank you, participants. Thanks for our valuable time. And if you need any internship, you please use this link to get a coupon code.